The world population of people above age 65 is expected to double over the next 35 years. But along with this increase in longevity, the burden of age-related diseases is expected to grow as well. One of the most common and feared signs of aging is the loss of cognitive function. A familiar challenge for the old brain is to find a car in a parking lot after a busy day of shopping. We use landmarks such as a storefront or a lamppost to try to make what neuroscientists call a map in our brain. Why the old brain does not do as well is not clearly understood. We know that with aging, neurons lose connections between each other, they start dying, and ultimately the brain will shrink. Such an old brain is less efficient than a young brain, and diseases such as Alzheimer's may develop. Now, interestingly, animals, including dogs or primates, have similar signs of aging, and even mice show memory problems as they age. In fact, we can teach mice learning and memory tests that use similar processes we humans use to try to remember something. Now, young mice do much better in these tests than old mice. So wouldn't it be great if we could halt aging and thus prevent cognitive decline and other age-related diseases? In fact, people have tried to do this for centuries and have dreamed of Dracula and vampires for a long time. A number of companies, biotech companies, are trying to do this now and target specifically aging to address cognitive decline and other conditions. The legendary Fountain of Youth, shown in this painting from Lucas Cranach, suggests that, or proposes that just drinking the water from this fountain will give you eternal life or youth. But what we show now, a number of groups at Stanford and elsewhere, is that blood may actually hold a potential fountain of youth. So to show you what I mean, we use a test in mice where they have to remember where the only hole is where they can escape from this bright light and open surface. Now, an old mouse does not do well in this test. You see in this example, this mouse is trying to use the spatial information to find the single hole in this table, but it cannot remember, it did not make a spatial map in its brain. In stark contrast, the mouse you see in the next slide is doing much better in this test. It seems to know its location and where the escape hole, the parking spot for it is. This mouse was treated for 3 weeks with young blood before the test, and by all means it seems to be rejuvenated and know this test. So we know that the rejuvenated brain of these mice not only functions better in a number of learning and memory tests, it also makes more neurons, it has less inflammation, and the neurons connect better with each other and function better. This is quite remarkable to us, but how does it work? Blood is the organ or the medium that connects all the organs. Blood, of course, contains cells that carry oxygen or fight diseases, but it also transports messengers that carry information between these different organs, including the brain. We call these messengers hormones, for example, or growth factors. Now we know from studies in our lab that these messengers are very different between young and old blood. In fact, we find that young blood has many factors involved in repair and maintenance of tissues, whereas in old blood we find factors involved in inflammation. So we think when we treat an old organism, such as the mouse I showed you, with young blood, we give it a boost of these young messengers. And that this recharges the old brain and possibly other organs and makes them function like younger ones again. We know that blood can do this, but we also learned already that most of the beneficial effects are actually in the soluble fraction, which is also called plasma. This offers the opportunity for us to isolate these factors, produce them synthetically so that we can use them as potential drugs to rejuvenate tissues and potentially help cognitive deficits and other conditions. So does this magic work in humans? To put this to the test, we started the company Alkahest, which is currently testing this idea in patients with Alzheimer's disease who are receiving young blood from healthy volunteers. Obviously, we don't know yet whether this will work, but we're very excited to learn a potential power that this young blood may hold. Thank you very much.
Thanks for watching.